Welcome back. This is the last and final video on the topic of vapor pressure. And as I said, I split it into three components. We looked at a non-ionic compound, and then a volatile compound and a solvent. Now a metallic compound. Ideally, this would be called just pure ionic, but I figured if I keep it metallic, I think it opens up the possibility and less confusion. So the equations are pretty much the same, but before we get there, why did I call it metal containing compound? Is because we go back to the start and look at the definition of colligative properties. It said a number of solute particle, and at that point I said the word number has a very particular importance, and this is probably going to be the hardest problem in this entire semester. And I think that's because there's so many steps that you have to do compared to all other problems you would see throughout the semester where things are very, very straightforward. I would say that it's not difficult, but it's definitely not going to be, straightforward. So let's proceed. I'm going to put all the equations up here, right? So we have, what is the vapor pressure of a 2 molar solution of K2SO4 in water? Density is given. It's not something we've ever done. Vapor pressure of pure water is given. So in this crazy Raoult's-law equation, this is already given to you. 99.9% of the problem involves solving this. And that would probably drive you crazy. And if you remember, there's one folder that said coming soon in 170, and I never actually created that one video. That's because I thought, well, I'm going to actually teach that concept again in this particular problem, so why bother create one video and just extend the content? So that video would replace this problem, okay? All right, so first let's do something. Let's take what you are so comfortable with and determine the molar mass of this, which would come out to be 174 grams over mole. And we already know the vapor pressure of pure solvent in this problem, which is 93 millimeters of mercury. So we're trying to solve this is our ultimate need, but then we also have to figure out this. And that's not going to come very easy because we've not learned this particular technique. So what you have to first do is, potassium is a metal. So in this case, before you proceed any further, figure out how many total species we have. Okay, K2SO4, right? This is one species altogether. There's 2 of these potassium, so 2 plus 1, 3. So when you have a metal containing compound, it doesn't matter what the metal is, you should be able to count. This is one full species, right? And then there's 2K. Don't say that you have 2 plus 1 plus 2 plus 1 plus 4. No, that's not right. Just 2 plus 1, 3 total. So first what I want you to do is take this 2.00 mole times 3. What would that give you is, sorry, forgot the M. That'll be 6.00 molar. That means that's actually the total concentration if you account for the number of species instead of 2 molar. Now what is molarity? So 6 molar is same as 6 moles over 1 liter. Let's stop there. Let's go, so that's the first step to the problem. The second step is we have to figure out, I'm going to add something else here. Mass of solution equals mass of solute plus mass of solvent. Why do I have that? Well, we'll come back to that in just a second once we finish step 2. Because there's 6 moles per liter, that's how many solute we have in 1 liter of a solution, right? So take this 6 moles, okay, and multiply by the molar mass of the substance to figure out how much in terms of mass does that correspond to. So that's 174 grams over 1 mole, which will be 6 times 174. It'll be 1,044 grams, right? So let me change this to say 1.31. Okay. Actually, no. Yeah, 1.31. Okay. Now I've changed the density because I changed this compound at the start. This was not the original version of this compound. So this is the mass of solute. Okay, I'm going to spend a little more time because I'd rather do this problem once, because doing it 200,000 times or doing 200,000 problems is not going to necessarily improve your understanding. Now we have to find something else, which is the most confusing step of all. Take this density, okay, this is 1 mil, convert this to grams per liter. So all you got to do is, there's 1,000 mils in a liter, okay, which would leave us with 1310, right, grams over liter. Now this is the mass of solution, okay. Now mass of solvent is what we need. So that'll be 1310 minus 1044. That'll be 6, 9 minus 4 is 5. 256 grams is the mass of solvent. Now we know the mass of solvent, which is water, and mass of solute. We can find moles of each of this and then find the mole fraction, okay? So 1044 grams, okay, over 174 grams, right? 1 mole, right? I guess we wouldn't need to do that step, but you know what? Let's do that. 144 divided by 174, which will give us 6 again, right? Which is, again, we're going forward and then going back again. So this is moles of solute, right? And then 256 grams. Sorry, I'm using every possible space to keep it within one screen. Water is a solvent. So 256 over 18 is 14.2 moles, right? Now, how do we find the mole fraction of the solvent, which is step 4? Solvent is 14.2 divided by 14.2 plus 6, which is 14.2 divided by 14.2 plus 6 is 0.70, right? And the 5th step is actually solving the problem, which is vapor pressure of solution equals 0.70 times the vapor pressure of pure solvent, which is 93. Oops. I was at the very end of the screen, so that'll be 65.1. And that's the problem. I'm not going to say much because some of you are probably wondering I'm insane or mentally disturbed or probably any other term. But imagine what it took for me to learn this concept way back when. Okay, this was one problem that's given me the hardest of the times when I learned it because of how many steps it has taken. Now it looks all red on the screen, but when you watch it, I've done it systematically. Okay, and I'm going to put these back because these are the 3 practice problems on all of the lowering vapor pressure concept that I have talked to you about: volatile, non-ionic, and metal containing compound. Okay, I'm going to leave this on this. You may have to watch it more than once. Okay, and that's the end of vapor pressure. I'll see you with boiling point.